Welcome to the Explainer. If you think cloud security is just about, say, slapping a digital padlock onto a physical server sitting in some dusty remote data center somewhere, well, you're in for a pretty massive paradigm shift today. Modern cloud environments, they are hyperdynamic, they're internet-facing, and literally almost every single resource inside them can become an attack target in the blink of an eye. Seriously, understanding these threats, it's not just some tedious IT chore. It is the absolute first step you need to take to build resilient, secure systems in our modern world. So, let's get into it.
Here's our roadmap for today. We've got 5 stops. First, the cloud paradigm shift. Second, expanding the attack surface. Third, common cloud security threats. Fourth, the defense in depth strategy. And finally, number 5, we'll walk through a real-world scenario.
All right, Section 1, the cloud paradigm shift.
Okay, let's dive into this first major concept. To really wrap our heads around the cloud security threat landscape, we kind of have to contrast it with what came before. Think of a traditional data center as this super rigid castle and moat type system. The servers are physical, they're locked down in a building, changes happen at a total glacial pace, and security teams know exactly what hardware is sitting in the racks. But the dynamic cloud? Wow, it's totally different. It's more like a bustling, constantly shifting modern city. It is entirely API-driven. Virtual machines, databases, containers, they can be spun up and completely destroyed in just a matter of minutes. Developers are out there deploying new apps multiple times a single day. You literally can't just guard a perimeter anymore simply because that environment is continuously changing.
Moving right along to Section 2, expanding the attack surface.
Because we're no longer just dealing with a simple static castle. We really have to recognize that our digital footprint has radically expanded. So I want you to ask yourself, what are we actually protecting in the cloud? Actually, it's really easy to just say data, right? But it's so much more than that. We're protecting the applications and the APIs that your users interact with every day. We're securing the virtual machines and the containers running those apps. We're guarding databases, storage, and, absolutely crucially, user identities and secrets. I mean, even the source code and configuration files themselves are massive assets now. If a bad actor compromises just one of these elements, they can potentially bring down the whole shebang.
Okay, so what does it actually mean to protect all those assets? Well, in information security, pretty much every single decision you make traces right back to the CIA triad. First up, confidentiality. That's all about keeping your data private, usually using tools like encryption. Second, we have integrity. This is ensuring data stays completely accurate and unaltered. You'd use things like digital signatures here, so an attacker can't just, secretly modify a banking balance. And third, availability. This is making sure your services are actually accessible when authorized users need them, which means having really robust backups and rock-solid DDoS protection. Basically, every cloud security tool you'll ever use is specifically designed to support one or more of these 3 pillars.
Now this brings us to a massive foundational takeaway. Because your users can access the cloud from literally anywhere in the world, and there's no real physical network boundary anymore, identity is the new security perimeter. Identity basically answers the question, who are you and what are you allowed to do? This makes identity and access management, or IAM as we call it, your true front line. And the absolute golden rule here? The principle of least privilege. That means giving users and applications only the absolute bare minimum permissions they need to do their jobs, nothing more.
Which brings us to Section 3, common cloud security threats.
Now that we know what we're protecting and the core principles we use to protect it, let's look at exactly how attackers actually operate. When we think of cyber threats, Hollywood has totally trained us to imagine these brilliant super hackers furiously typing green code on black screens, right? But the reality? The vast majority of attacks don't start with some super advanced technical exploit. No. They start with simple credential theft, a careless click on a phishing email, or just human error that leads to data leakage. Attackers are lazy. They are looking for the path of least resistance. They'd much rather just log in as a legitimate user than try to hack their way through a complex firewall. They'll also use ransomware to lock up critical databases, exploit insider threats, or even target your supply chain by compromising the third-party software you already rely on.
In fact, one of the most terrifying threats out there isn't actually a malicious attack at all. It's a cloud misconfiguration. This happens when a resource is just set up incorrectly, usually due to a simple human error. Imagine, and this happens all the time, checking the wrong box on a cloud storage bucket and unintentionally turning your company's highly sensitive internal customer data into a publicly accessible web page. Oops. Seriously, small, completely innocent mistakes in configuration create some of the absolute biggest real-world risks we face today.
And hey, speaking of simple mistakes, let's talk about secrets. In this context, a secret is any highly sensitive piece of information, like passwords, API keys, or access tokens that allows authentication. Think of a secret exactly like a master key to a physical building. One of the absolute most dangerous things a developer can do is accidentally store these secrets directly right there in their source code. Why? Because attackers actually deploy automated bots that continuously, 24/7, scan public repositories looking for exposed secrets. In some cases, an exposed key can be found and exploited by a bot in mere seconds. Literally seconds. If they find yours, they can bypass all your other security controls in an instant.
To combat all of this, you need what I like to call the essential toolkit. We're talking about Linux fundamentals here, like managing permissions and analyzing system logs. We're talking about networking concepts, really understanding IPs, DNS, and protocols so you know exactly how your systems are communicating. And of course, we're talking about container technology, like Docker, which packages up your apps but requires its own specific runtime security. Now, don't view these technical prerequisites as tedious chores. They're not. They are your empowering toolkit. Honestly, you simply can't secure a cloud server if you don't first understand the operating system or the network traffic flowing through it.
Let's jump to Section 4, the Defense in-Depth Strategy.
So how do we actually solve this giant cloud security problem? Well, the crucial point is this: no single security control is ever enough, period. If you think just buying the most expensive, perfect firewall is going to keep your cloud safe, I hate to say it, but you've already lost. Defense in depth means consciously, intentionally designing multiple, overlapping layers of protection. That way, if an attacker somehow manages to bypass one layer, say by stealing a password, another completely independent layer is right there waiting to stop them dead in their tracks.
Let's look at what those overlapping layers actually look like in practice. First up, identity protection. That blocks unauthorized users right at the door. If they somehow get past that, network controls kick in to restrict where they can actually go. Then, application and infrastructure security ensure there are no easy vulnerabilities for them to exploit. On top of that, data encryption means that even if they do manage to steal the data, it's just gibberish. They can't read it. And finally, monitoring and detection sit on top of the whole thing like a hawk. By stacking these layers, you create an incredibly robust system of prevention, detection, and rapid response.
But hey, remember what we said earlier? The cloud moves at blinding speed. You physically cannot manually check thousands of virtual machines every single day. Manual security simply doesn't scale. To really secure the cloud, you absolutely must rely on automation. That means utilizing infrastructure as code so your servers are built securely by default. It means running automated security scans before anything ever gets deployed. And it means utilizing SIEM, that stands for Security Information and Event Management, to continuously, endlessly monitor your logs. Automation is what gives you that continuous visibility you need to survive.
And finally, Section 5, a real-world scenario. Let's see how all this builds into a tangible narrative, kind of putting all these theoretical concepts to the test. Here's the anatomy of an incredibly common but highly damaging breach. Step 1, a well-meaning developer accidentally commits a secret, let's say an API key, into a public source code repository. Step 2, an attacker's automated scanning bot discovers this exposed key within minutes. Literally minutes. Step 3, because they now have a valid key, the attacker gains direct, unauthorized access to the cloud infrastructure, totally bypassing those network firewalls we talked about. And Step 4, the attacker quietly downloads and steals sensitive customer data. It happens so fast, and unfortunately, it happens all the time.
But wait, let's look at how defense in depth could have, and frankly should have, stopped this at multiple different points. Let's work backward for a second. If the developer had tried to commit the key, automated security scans should have flagged that secret and blocked the deployment immediately. Boom, stop right there. But okay, let's say it slipped through. If the attacker used the key, the principle of least privilege should have ensured that that specific API key only had access to, limited testing environments, definitely not sensitive customer data. And even if they somehow got to the data, continuous SIEM monitoring should have instantly spotted a massive, unusual data download coming from a foreign IP address and shut that connection right down. Layered security totally saves the day.
And that brings us to the ultimate question. You now understand the incredibly dynamic nature of the cloud, you see this massive expanding attack surface, and you know the sheer power of defense in depth. But are you ready to actually build the continuous defenses needed to withstand these threats? Listen, cloud security is not just some product you can buy off a shelf. It's a continuous, evolving mindset. I really hope this explainer has left you eager to roll up your sleeves, maybe spin up your own secure lab environments, and start building these powerful, layered defenses for yourself. Thanks so much for joining me.